Hello. Hello.
हेलो.
Ma'am, am I audible?
हाँ हाँ, you are audible तो.
Hello.
Yeah, you are audible.
That theme speaker is what? Tyagaraj?
Yeah, team speaker is Dr. Tyagaraj, and sir, you can introduce him as a chairman of the session.
Acha, but I do not have any details. But anyway, whatever I know about him.
If you want, I can share it. I have it now.
Okay.
I'll just share it.
From WhatsApp.
Yeah, I'll be sharing. That's much easier for me. Actually, I compiled for whom I have to do it or related to where I am involved. So that's why yours and others, Dr. Ankis, everybody is in the same document. So kindly consider only.
Okay.
Done, sir.
Okay. Yeah. And what about Dr. Tyagaraja?
Maybe he may join at 4. So we still have 8 minutes. So let's wait.
Okay. No, this now what is the time? 3 minutes to left. 3 minutes.
In my clock, it says 3:53.
Okay.
Good afternoon, Chitra madam.
Man, kindly post it in the chat box.
Good afternoon, Dr. Nilima. How are you?
No, already.
Yeah, I'm good. Happy to see you.
Yeah,
Okay.
nice to see you.
Madam, you can wind up the session so that at 4 o'clock you have to have your team presentation.
So once again, we thank all the distinguished.
Good afternoon, everyone.
Yeah.
Good afternoon.
Good afternoon, madam. Good afternoon, Professor Vaidya.
Yeah. So,
Good afternoon, Dr. Tyagaraja.
Yeah, good afternoon, Dr. Nilima. Professor Ankit Garg has joined. Good afternoon, Professor Ankit.
yes, he is there.
Good afternoon. Good afternoon, Professor Thyagaraja.
How are you,
Yes.
sir?
I'm good. I'm good.
Good.
Yeah.
Hello. Sir, can we start?
Yeah, we can start.
Okay. So, good afternoon, everyone. I welcome you for this parallel session for the Team 4 under Environmental Geotechnology under IGC 2020. It's my privilege to coordinate this particular session. We have a very interesting talk by the theme lecturer, Dr. Tyagarajan from IIT Madras, and followed by the presentations by the, we have 13 papers, so let's see whoever are available, so that will be. So for this particular session, we have a very senior professor, Professor Vaidya from IIT Kharagpur, who will be chairman for the session. And we also have Dr. Ankit Garg from Shanto University, who will be the co-chairman. So I'll just take a few minutes to briefly introduce our chairman and the co-chairman. Professor D.K. Vaidya, he is presently professor at IIT Kharagpur in the Department of Civil Engineering, and he graduated in 1987 from BE College. And then ME and PhD, he did it from IIC Bangalore in the year 1989 and 93 respectively. He had a vast experience of almost 27 years in teaching and research and consultancy in different sub-themes of geotechnical engineering. He has published several papers in top international journals and national journals, and also received 3 best paper awards from different societies. He visited several countries and served 2 years in University of West Indies, and also extended his services to different for solving different industry projects as a consultant. And he was a member of TC1 of ISMGE and also elected member of IGC since 2017. So, sir, we welcome you virtually for this session. And I also take to introduce opportunity to introduce Dr. Ankit Garg, who is very active researcher in the environmental geotechnology in the last, I think, 10 years. He obtained his PhD from Hong Kong University of Science and Technology under Hong Kong PhD fellowship scheme. He did Guwahati from 2006 to 10 there, and then he followed and he joined as an assistant professor at IIT Guwahati in 2015 and served for 2 years. He was a part-time World Bank consultant too for monitoring transport and infrastructure projects in Assam. So he has a research focus on development and utilization of sustainable materials, especially biochar and fiber, including vegetation for geoenvironmental applications. He published 92 papers in Web of Science publications, had a good amount of citations for that. And he has a top papers in several top journals, including Canadian Geotechnical Journal of Cleaner Production and many more. And I just try to make it so brief because his resume has so many things. He got a lot of awards as well. He was serving as, editor of a special issues in ACE and damage mechanics and the geotechnical, geosynthetics and ground engineering journals at present. And he got international awards also, especially from China. He got awarded as Talented Young Scientist Program and Young Doctor Award from Minister of Education from Chinese government. And he's working on several projects, international projects especially, and he was also got Fast Track project from SCRP India. So it's my privilege to introduce both of you, sir, and I request Chairman Professor Vaidya to take over. Thank you so much.
Thank you, Nilima, Professor Nilima, Dr. Nilima. And I hope I am audible.
Yes, you are.
Okay. So now this session, we two, Dr. Ankit and myself, will be conducting this session. And we have one theme lecture by Dr. Tyagarajan. And there are around 13 papers listed here. We do not know how many finally to be presented. And so we'll see that. But better, I think we will plan, first of all, I will introduce the author and then invite the presentation. And then after presentation, I'll request Dr. Ankit at the end to maybe summarize what is presented here. And then finally we'll conclude the session this way. So right now I will be inviting Professor Tyagarajan. And before inviting, actually, I'll just give a very brief about him. the true sense to introduce to the audience here. And so Professor Tyagarajan was presently a professor at Department of Civil Engineering, IIT Madras. He obtained his BE from Osmania University and MSc and PhD from IIC Bangalore. He worked as an assistant professor at the Department of Civil Engineering, NIT Warangal during 2006 and 7. He had a brief stint at King Saud University as a research fellow and as an assistant professor during 2008 before moving to IIT Madras. His research interests include unsaturated soil behavior, ground improvement, and geoenvironmental engineering. He has published 33 papers in reputed international journals, 3 ASC special publications, 3 book chapters, and 1 edited book. Professor Tyagarajan received prestigious IGS Professor Dinesh Mohan Award in 2016. He has served as an editorial board member of International Journal of Geotechnical Engineering. Professor Tyagarajan is an active executive council member of IGS Chennai chapter. He is a qualified NABL assessor for IEC. So with this, before inviting, let me talk a few words about that geoenvironmental engineering. Geoenvironmental engineering right now, obviously, it is a very important topic. And in fact, maybe 25 years back, it was not that way we discussed, particularly when we have studied environmental engineering we are talking about, but geoenvironmental, not such a big way, the way we talk about nowadays. And in fact, geoenvironmental engineering means actually sometime we use different types of foundations. Based on geoenvironmental condition, you have to select the foundation type. Otherwise, some foundation may not be suitable for some environment. At the same time, that because of several geoenvironmental issues, the soil properties also will change over the time. And until unless we assess properly and take care, then it will affect the foundation in future. So this is the way actually we can talk about the geoenvironmental engineering. But Professor Tyagarajan is the expert on this area. I'll first request, I will hear from him to learn more about it. And obviously, subsequently, other papers will be presented. And from there, we will understand where we are now on geoenvironmental engineering issues. So with this, I'll invite Professor Tyagarajan to present his lecture. And maybe what is the time schedule for him? 15 minutes or
20 minutes for the theme talk.
Okay, 20 minutes. Professor Tyagarajan.
Thank you. Yes, sir. Thank you very much for the kind introduction. Thank you very much, organizers, for giving me this opportunity to share my research, which I have carried out in the past few years. Give me a moment. I will share my screen.
Yeah, please.
I think I need to given permission. I think I am unable to.
Yeah, there is a from
administrators. Can you give me permission, please?
Give the permission. Tulsi, I'll call her, Dr. Tyagarajan.
I think I'm trying. It's coming. I think, madam. Just I will try once. Can you see my screen, please?
Yeah, it's coming.
Thank you. Thank you. Yeah. Thank you very much for the kind introduction. Today, I'm going to discuss on the physicochemical interactions and cyclic wet-dry process on the behavior of compacted soils. So this is co-authored by my student, Dr. Julina, who is a faculty at NIT Pondicherry. So the presentation, I will follow this outline. First, I will introduce the problem, discuss its importance. Then I will try to bring out the recent studies on the desiccation cracks, mainly using the XCT imaging, so X-ray computed tomography imaging. I will how to quantify, and then I will discuss about the effect of physicochemical interactions and wet-dry processes on the behavior of clay liners. Then finally, I conclude with summary and conclusions. To start with, so the physicochemical effects. So it has its importance, or they arise in geoenvironmental engineering problems, such as clay liners in landfills and so on, and brine ponds and other examples. So wherever we have any contamination, there the need arises to study about the physicochemical effects. Further, it is well demonstrated in the literature that the soil structure has a bearing on engineering behavior, and that too especially for clays. So it has a lot of significance. Since the physicochemical factors, they affect the soil structure, so they indirectly affect the behavior of clay soils. It is well established in the literature. When we say physicochemical factors, they primarily refer to the changes in Coulombic attraction and repulsive forces and the arrangement of particles. We can broadly classify this into two components. One is, one is compositional factors and the other one is environmental factors. So when we say compositional factors, the type and amount of each clay mineral, type of absorbed cations, pore water composition. So when we say environmental factors, water content, density, confining pressure, and temperature. These are the factors which govern the behavior of physicochemical behavior. Now, further, it's not working. Not sure.
Nick, it is not going to next page.
It's not going. Yeah, fine. So coming to the physicochemical effects, as I said, it is very well studied in the literature, very extensively, but most of the studies were focused on reconstituted clays. So you can see that there are classic studies by Mesri and Olson, so mainly on the compressibility characteristics and as well as hydraulic conductivity. You can see that it has a lot of bearing on compressibility characteristics. You can see the E-log-P curves are presented here. So you can see that the void ratio drastically decreases. You can see 35 is a void ratio with distilled water. It comes to close to 5 if it is slurry consolidated. So such is the effect on that. And they have also beautifully brought out as the hydraulic conductivity increases as the pore fluid concentration increases. You can see that. So I need not discuss. This is well demonstrated that the slurry consolidated soils have physicochemical effects, have a lot of effect on the slurry consolidated soils. But however, there is not much understanding on the compacted clays. Compacted clays, they differ in the mainly on the characteristics. So mainly it differs. Compacted clays, they are characterized by both matric and osmotic suction, but whereas the reconstituted clays are only characterized by osmotic suction. When we say the unsaturated soils, mainly the expansive soils and collapsible soils, we can call them as unsaturated soils. And if you can see Fredland, he gave generalized world of soil mechanics beautifully in this figure. You can see. So this is the water table. Below the water table, we have saturated soil mechanics, where we have positive pore water pressure, and above the groundwater table, it is not saturated, it has negative pore water pressures. So here, only one stress state variable governs the behavior of the saturated soil, that is effective stress state, sigma minus UW, we very well know from the classic soil mechanics. But whereas unsaturated soil behavior is governed by two stress state variables. One is net normal stress, that is sigma minus UA, and matrix section UA minus UW. Having said that, now let us see how this structure of the compacted soils are there. Usually, the slurry consolidated soils, they have monomodal structure, only single one structure. But whereas the compacted soils have double structure. One is comprised of macrostructure, and other one is comprised of the microstructure. This microstructure, so the particle arrangements, clay particle arrangements, they can be arranged either in dispersed structure or flocculated structure. We call them as intra-element pore, and these intra-element pores, they constitute an aggregate, so such as this. So between the aggregate, there is a pore that we call it as interaggregate pore. So and if these aggregates, if they are combined together, you can see on the right side. So these are different aggregates. There is a space between them that we call it as interaggregate pore. So or macropore. But whereas these pores we call as intra-aggregate pore or micropores. So that's why the behavior of the compacted clays is usually to have double structure, but whereas reconstituted soils has monomodal structure. Having said about that, so schematically, so here is the real behavior of the pore structure presented by Monry. You can see that there is a macropore peak here, and similarly a micropore peak. So in the compacted soils. So as I said, to summarize, since the structure is different and the structure governs the engineering behavior of the soil, we can say that the behavior of compacted soils would be quite different from the behavior of reconstituted soils or from slurries, owing to the difference in structure and unsaturated state. Now, the compacted soils are used in landfills and various environmental engineering applications. Especially, we use clay soils or expansive soils. So these expansive soils, if we talk about them, they have a tendency to undergo swell and shrink due to changes in seasonal moisture contents in wet and dry seasons. So swelling is a very good characteristic. It will help us in healing the cracks, whatever the cracks that are developed. You can see on the right side a picture given by Albert and Benson. So you can see that a lot of desiccation cracks are there. So these cracks will heal. Hello, am I audible? I'm there, right?
Yeah, you are audible actually. Only the full screen has gone.
What is the problem, madam?
No, you are audible. Only the screen was full screen was not there.
Thank you, madam. So what happened is I was getting calls. So I thought one of you are calling such that my internet connection was lost because I cannot see what's happening. That's why I'm very sorry for that.
Yeah, now.
You can see my screen, sir?
Yeah, screen, I'm not seeing anything. It's like blank actually. Something.
No. We are seeing. We can see your screen. You can continue.
Thank you. Thank you.
Screen is okay now.
Thank you. Thank you very much. Yeah, sorry. So swelling, it assists in the healing of the cracks, whereas the shrinkage and cracks that amplifies the infiltration through the cracks. Whatever the cracks that are there, water can easily enter through and it amplifies. Further, when we have a leachite, the interaction between the leachite and the clay, so that will alter the swelling and shrinkage behavior. So for that reason, it will also affect the behavior of the clay soils or compacted clays or compacted. Thus, we can say that the wet-dry cycles and interaction of leachite alter the engineering behavior of clay soils and in particular, the hydraulic conductivity. So thus, my study is going to bring out mainly, we are going to study the effect of wet-dry cycles and interaction of the pore fluid on the behavior of clay soils. So before I bring out, I would like to just present very quickly how the osmotic suction affects the behavior of clay, especially the soil structure. So what we have did is, we have taken 3 moisture contents. So one is on the dry side, optimum side, and wet side. And we have mixed with 3 different pore fluids. One is distilled water and NaCl solution and CaCl solution. And we compacted to the same density, all the samples. So you can see while mixing itself, whatever the PET size are different. With the distilled water, you have a small PET, but whereas this has a larger PET, you can see. So this is the compacted specimen. When we did that, and we measured the matrix section using the filter paper method and total section using the filter paper method, and the pore fluid using the pore fluid squeezing, osmotic section using the pore fluid squeezing technique. When we did that, so when we measured it, we saw clearly from these figures, you can see that with the increase in pore fluid suction, that is with the concentration of the pore fluid, you can clearly see the matrix section is increasing at all the wet, dry of optimum, and wet of optimum. And for both NaCl and CaCl2 solution, both. And with CaCl2 solution, it is slightly higher. And similarly, as the matrix section has increased, obviously the total section also has increased with the pore fluid section. Why it happened is, when we have mixed with the pore fluid, what happened is, you can clearly see schematically. So this is the distilled water phase diagram, and this is the phase diagram of specimen mixed with the salt solution. You can see that the volume of the soil remains same because the density is same. Only the micropore volume is more in case of distilled water remolded specimen, and microvoids is also more. But when relatively the microvoids of the salt solution decreased because of the suppression of the diffuse double layer, and that has led to the increase in the macropore. So since this happened, so this also can be seen through the SEM. You can see that clearly this has a uniform fabric distilled water, but whereas with the salt solutions, it is aggregated. You can see that the macropore size are increasing because of the aggregation. For that reason, since the matrix suction is a characteristics of the macropore and the degree of saturation of the macropore, with increase in pore fluid suction, osmotic matrix suction increase. So far, there was understanding that it will not increase, but this was published in Geotechnique in 2015. And then, since it is having an effect on the suction components, we thought it will also have an effect on the hydraulic conductivity behavior, and also it should affect with the leachite and so on. So we further continued the study, and we have proved that these measurements we made independently and as well as measured independently and total section thing, they are showing that the measurements are accurate. Without spending much time, I would like to go to the next thing, that is a quantification of desiccation cracks using XCT image. So if you can understand where the desiccation crack is occurring and how it is occurring, then it will help us in understanding the hydraulic behavior. So first I will explain how we have carried out this quantification of desiccation cracks using this XCT images. You can see that in this slide, we have compacted the soil in the odometer ring, and when we have dried it, you can see that this is during the first drying, there are not much cracks, and there are no cracks, only the annular gap was there, soil was shrunken. But whereas during the subsequent drying, you can see that there is an annular gap and crack formation. So both are there. So we have used this setup for carrying out the wetting and drying cycles. We have used the soil from Chennai. So it has a liquid limit of 78 and clay content of 82%. And the free swell index was 105. That's how, and we did wetting and drying cycle. We have used 3 fluids. So distilled water, 0.4 and 4 molar NaCl solution. So during wetting, we have monitored the volume change and water content. And after wetting, we dried it. So at the end of wetting, we measured the hydraulic conductivity. Then the same sample, we dried it, and we monitored the desiccation cracks during drying and at the end of drying, and as well as water content. Once the water content is below the shrinkage limit, then we said that there will no volume change. That is approximately 4%. We stopped and we went to the next wetting cycle. So we repeated until the equilibrium bandwidth has happened. So you can see that we have used a simple digital camera, so which is having a 20.1 effective pixels. This is the arrangement. The camera was kept about 150 mm above. Sample was here in the odometer ring. You can see that images were captured at different timing. You can see these are the left side one is the top surface camera image. Right side one is the bottom surface camera image. And we have also taken out the ring. We have taken the lateral shrinkage also, and we have stitched them together to get the lateral surface image of the soil. So this was used as just as a digital camera image, and then further we have used, because this only gives only the surface reading, either on top or bottom or on the circumference. So in order to know what's happening inside the soil sample, we went to the XCT, so X-ray computed tomography method. So we have used, this is the arrangement for that. This is a typical 3D reconstituted from this 3D image XCT machine. You can see that. So here is a lateral stitched sample I have showed. So at different depths, A, B, C, and D, we have taken the XCT images. You can see that A, B, C, D, and E. So these are taken at approximately 25% depth, 50% depth, 75% depth, and 90% depth. So how we have calculated the volume of the sample, removing the volumetric sample, removing the cracks area that is shown here, and we have used the images software for doing it. So this further shows very clearly that further during the second drying cycle, we have shown the images which are captured at different depths. So on the both sides, first column and the last column, they are the digital camera images, and in between were the XCT images. You can clearly see. So the after the first second swelling, the water content was 52%. But when we dried it, water content gradually decreased, and you can see these XCT images and digital camera images. There were no cracks here, and gradually the cracks increased. When you see these last two rows, the crack pattern is almost same. Means once it is reached the shrinkage limit, after that there is not much change. And when we have computed that same, you taking this specimen and measuring it through the images software, the area of cracks, and when we have computed, we have plotted like this with the depth of the sample. You can see that the cracks area at the beginning is 0. As with the water content, you can see it increases this red color one at 28.3%. When it comes, the cracks area is maximum, and then as the water content still decrease, again the cracks area decreased, and you can see that this is the cracks area at the 4% water content. Why is it so? Because initially the sample shrunk, and because of the global shrinkage of the sample, the cracks volume has reduced. Cracks volume increased with the water content, then decreased. That you can clearly see. Further, you can see that with the depth variation, at the surface cracks were more and the bottom cracks were more, but in the middle portion, the cracks were reducing, you can see. And there is one small kink here that suddenly it increases because of the lateral crack that was formed at that depth. So that is because of this lateral crack, this have increased. Now further, the effect of physicochemical interactions and the wet dry cycles, wet dry processes we carried out to understand the behavior. You can see that this is the volume change of the 3 samples. We have used 3 samples: distilled water, 0.4 Na and 4 Na specimen. So you can see that the volumetric change, so after third cycle it became constant. So equilibrium has attained after third cycle. Same thing with the 0.4 molar NaCl solution and as well as 4 molar NaCl solution as well. But however, the volumetric shrinkage of 4 molar NaCl solution is far lower than that of the distilled water and 0.4 molar NaCl solution. From this figure, you can see that 0.4 molar solution, it is not having much effect on the volumetric shrinkage here. Further, we have used the XCT method, and we have also shown here. One is digital, one is with the vernier calipers, just the vertical measurements. Using that and the area, we have calculated the volumetric deformation, and we can clearly show that. Using the different fluids, we have shown with the XCT measurements also, you can clearly see that the volumetric shrinkage has increased a lot. So this is how we computed. I will not go into that. It's just a basic one. Now, we wanted to further show how will be the images are during different wetting and drying cycles. So these images are mainly the drying cycles. You can see with distilled water, so you can see, sorry for that, yeah. With distilled water, you can see that first drying there are no cracks. The same is with all the specimens for 0.4 molar and 4 molar NaCl solution. But whereas during subsequent drying cycles, you can clearly see the cracks area, cracks are increasing. Not only the shrinkage, cracks are also increasing. Here, when it comes with the 0.4 molar, the behavior is more or less same. But whereas with respect to the 4 molar NaCl solution, you can clearly see that the volumetric shrinkage of the specimen is very less. The cracks are not much visible on the surface. But when we have taken an XCT, we have seen that there are a lot of cracks. So you can see this is the XCT, just 2% below the surface depth. If you can see, these are the cracks. And if you go deeper, a lot of cracks are there. So you can see that in the distilled water sample, a lot of cracks are there, and even with the 0.4 molar solution, cracks were developed. But whereas the 4 molar solution sample, you can see that the structure is porous and the cracks are appearing at the same place. That is the case for the case of 0.4 molar also. It occurred at same place after fifth drying cycle. Sir.
Professor Thiagraj, can you, because the time is almost.
I will conclude, sir. I will conclude. So I need just 2 or 3 more minutes, sir. Sorry. Sorry, because of actually we have some closure. I could not go to the academic zone. I'm doing it from home. Some disturbances that I'm.
Oh, no problem. No problem. No problem.
Yeah. So we can see that with the 4th drying cycle and the 5th drying cycle with 0.4 molar NaCl solution, you can see the cracks is occurring at the same place. But whereas in case of 4 molar NaCl solution, it starts to happen from the 3rd cycle itself. Right. And we have further, we have we have reconstructed these images using the XCT software, images software. You can see the crack pattern, crack is occurring at the same place in case of 4 molar NaCl solution. But whereas in case of distilled water specimen, it was not occurring at the same place. Why is it so? Because the healing of the crack is taking place in case of distilled water where we do wetting and drying. But whereas with 4 molar NaCl solution, the healing of the crack, even though occurs, it's not occurring completely, and the crack occurs at the same place. So for that reason, we have also studied the structure using the MIPs. You can clearly see from this figure that with the distilled water, the macro pore size is here, but with 0.4 molar, it has reduced. This is during the first wetting cycle. But whereas when you compare with 0.4 molar and 4 molar, you can see clearly the macro pore size increased for the case of 4 molar. Because of the suppression of the diffuse double layer, the macro pore size is reduced. Whatever we discussed earlier, macro pore size has increased. Same thing can be observed during the subsequent cycle. I'm not going into the detail. I think I took more time in the beginning. Same thing can be observed even at the 5th wetting drying cycle. For example, at 0.4 molar solution, you can see here this one. And when we observe the 4 molar solution, you can see the macro pore size is increased with respect to the 0.4 molar specimen. So when we compared with the distilled water and 0.4 molar, obviously the behavior was same as we have seen there also. The same thing is conveyed in the SCMs as well. There we can see the macro pores in the salt remolded specimens. And further, when we did the hydraulic conductivity, we can see that in case of distilled water, even after repeated wetting and drying cycle, you can see that the hydraulic behavior was same, and with 0.4 molar also, it was 10 power minus 7. Similarly, when we see here with the 4 molar, the hydraulic conductivity increased drastically and it became stable around 4th or 5th cycle. So further, what
Voice stopped.
Yeah. Totally.
Professor Thiagraj, we cannot listen you.
It is net issue.
Professor Bedia, shall we wait or we can?
Just 1 minute. Because we need to conclude. He has left the meeting and he is joining again perhaps. Just 1 minute, then let us see. I think he has finished almost his part. So he could not join yet. So let us proceed with other presentations. Almost done. And I thought of seeing if there is any question, and then 1 minute I could have given. But anyway, at the end again, if he comes, we will see that. Now, actually, we have 13 papers. Whether we should check whether they are there or not, or 7 minute time to everyone should we give?
I think it is okay. 6 to 7 minutes roughly.
6 to 7 minutes we'll give and start. Let's see where we can end. Okay.
Okay.
So, theme 4, paper number 1, strategies and learnings in execution of filter works with manufacturer sand in Earth and Rockfill Dam by Binod Kumar Moiria. Is he here? Binod Kumar.
Yes,
Yeah.
he's in the meeting. Yes.
Okay, please join quickly. Yeah, Binod. Okay. Okay, I'm not hearing you. Please.
Dr.
Unmute.
Maurya ji, you are unmute.
Unmute, Mr. Binod. Yeah.
Am I audible now?
Yes.
Okay.
And next person can be ready. We'll see. The next person will be paper number 2. It will be Abhishek, A. Srideep, and Uttam Manna. So this, if they are there, please be ready.
My screen is visible to all of you?
Yes. Now visible.
Good afternoon, everyone. Myself, VK Mourya. I'm in NTPC. This paper is basically the learnings during the challenges we faced in hydropower project of Earth and Rockfill Dam. This material we use filter works in the Earth and Rockfill Dam. So earlier, normally natural river sands are used. So here in one of the Earth and Rockfill Dam of NTPC, we propose to use filter material as a manufactured sand. So a lot of challenges we faced during execution and exploration of this filter material. So that I would like to present. Presentation outline will be introduction and the manufactured sand as a filter material, which was envisaged in this Earth and Rockfill Dam, and the execution methodology, what we adopted to do the successful completion of the work, and the challenges what we faced during actual execution of this filter material, and the exploration of this material from the query source, and the conclusions what we learned. So introduction, as you could see, there are two figures shown at the top. This typical cross section of our main dam is shown, which was 167 meter high Earth and Rockfill Dam with the center impervious clay core, and on either side shell material are there. There are 10 different types of materials, but this paper is focusing on the quartzite material, which was used as a filter material in the main dam and in the coffer dam also. So the total requirement was about 8.5 lakh cubic meter, and to achieve the constructional advantage, we explored the nearby area of our project to find the required quality of the material and successfully complete the work within the time. So at the right bottom, you could see the layout of the picture. So this is the.
I am not seeing your PPT. Others are seeing.
Yes,
I'm
we are
not seeing
seeing.
it.
We can see.
Yes,
We can
yes.
see.
We can see.
Yeah,
We can
it's
see. PPT.
visible.
Okay.
At the right bottom, the typical layout of this project is there, which indicates that there is a possibility of different quarry materials which were supposed to be used in the earthen rockfill dam of NTPC. So we explored initially what kind of materials are there, and we found that sufficient quartzite quarries are there which can be used as a filter material. So even then, it was a preliminary investigation before the start of the project, but during actual execution, when we started actually querying that material, we faced a lot of difficulties technically as well as during execution also. So the manufactured sand, what was envisaged in this project was having basically two roles to ensure the transition between materials with different gradation in the dam body, and to prevent the internal erosion in case a water path occurs through the impervious clay core which is at the center of the main dam. So the selected filter was supposed to be cohesionless in order to avoid development of cracks through the filters, which could lead to major leakage and piping during operation of the project. What execution methodology we adopted? So the temporary storage, we ensured that we should ensure temporary storage where we can control our requirement of the quantity as well as the quality requirements. And the placement during filling, we identified the number of equipments what should be used, and that procedure how to handle the material from the quarry to the processing plant, and from processing plant to the actual execution site at the main dam. And the compaction methodology we derived from the test sections which we did at many locations from different quarries to find out the lift thickness and the compaction parameters. Protection arrangements were necessitated to avoid any contamination at the various stages of the processing as well as during actual fill. So we derived the execution methodology for these requirements. And during actual execution, we faced certain challenges. The first challenge was that during query, at the query exploitation itself, a lot of clay seams were coming in between the different layers of the quartzite quarry, and silty materials are also there. So we were not getting a full-fledged 100% quartzite quarry. So from query, we need to isolate those materials and identify these clay and silty materials, segregate it, and then take to the our processing plant. So there itself, we necessitated additional measures while loading the materials to avoid mixing of the clay and silty materials with the quartzite. And the details could be seen in the paper, but these are the brief about the challenges. The next challenge was during crushing and screening. This quartzite was very hard, so all the initial jacks and the tools were getting damaged very frequently. So number of additional crushing plant was necessitated to produce the required quality of the filter material. And the next challenge was to control the fines during crushing. In the quarry, it was difficult to completely remove all the overburdened materials, vegetation, soil, though it was segregated, but 100% removal was not possible at the quarry. So we took the material to the crusher plant, and there we provided an additional screening machine with the spraying of water to remove the contaminated unwanted materials. Next challenge was in controlling the clay fines. Our requirement of PI values were 7 to 10. However, this PI values in this filter material was 5 to 11%, though percentage fines were less than 5% as per the requirement of our IS codes and international codes, but these PI values were very high, which were indicating that there is a percentage clay which is not good for our filter material. So this necessitated additional washing plant where we washed all the filter materials to remove this clay fines. The next challenge was the heterogeneity. There were a lot of heterogeneity in the quarry itself. So at the stockpile, we mixed properly to provide a homogenized material as a filter material. The next challenge was during execution, during the foundation preparation, a lot of continuous open joints were observed in the dam body.
Dr. Vinod, yeah, try to complete in a minute, I think.
Okay, thank you, sir. So that open joints and the shears were caulked and filled properly with the mortar concrete in order to avoid any potential migration of the fine material inside these joints. The next challenge was that during actual execution, some of the quantities were short due to all these challenges. So we tried to find another alternate material which was locally available as a limestone and dolomite, but that was having a problem of calcareous cancrations. So that was avoided. So we evolved that there are a lot of big size boulders available which could be crushed and used in the filter material. So that was also explored because of the short of the quantity, and it was very successful because the boulders were having a lot of percentage of this quartzite. So through that, we could overcome the challenge of the quantity shortage also. And the conclusions, what we learned from this, that results of the various laboratory tests were to be conducted at all the stages, at the query stage and processing plant and actual execution at site, to control the parameters, because there are possibilities during handling, during mixing, the contaminations may occur. So all the technical requirements need to be checked at all the 3 locations: query, processing plant, and actual executions also. And during execution of the filter works, it poses various challenges which can be overcome with the various alternatives, but quality compromise should not be there, so that our intended purpose is met, and we have successfully achieved our intended purpose without compromising on the quality, and our project is successfully operational at this stage. So it was a good learning. So I wanted to share this much of the learning with you. Details are in the paper. Thank you all.
Okay, thank you. Should we go for a question? If there are any question, one could, or should we go for next presentation? Anyway, let us one question. Okay.
Yes, please.
Who's you are not good.
Yes, please.
No question. Okay, so then we will go for next one. Okay.
Thank you. Thank you very much.
Thank you. Okay, so there are second paper. Actually, it is theme 4.002. The paper title: Performance of an Electromagnetic Sensor for Field Monitoring of Volumetric Water Content in Water Absorbing Polymer Amended Soil, Polymer Amended Soil, by Abhishek S., Srideep S., and Uttam Manna. Is any of the authors are here?
Yes, sir. Yes.
Okay, please. Who is presenting?
Abhishek.
Okay. Please take 7 minutes approximately, not more than 7 minutes. If you can finish 6 minutes, this will be nice.
Okay, sir. I'll try to finish within time. Dr. Vinod, can you stop sharing the screen?
Sorry. Thank you.
Okay. Just let me upload that. Also, Doctor,
Yeah.
Okay. So, good afternoon, everyone. I am Abhishek Shah, research scholar in the Department of Civil Engineering, IIT Guwahati, working under Professor Sideep Sekharan. And the topic of my today's discussion will be performance of electromagnetic sensor for field monitoring of volumetric water content in water absorbing polymer amended soil. So first I will discuss about what is water absorbing polymer. So water absorbing polymer are chemically cross-linked three-dimensional network with a lot of free hydrophilic functional groups. So it has similar structure like the commercial biopolymer, but the main difference with the biopolymer is its solubility. The biopolymers which we used for soil stabilization is soluble in water, but in water absorbing polymer, due to this cross linking, these polymers are insoluble in water and form a gel type of structure. So that's why it is also called as hydrogel. And a typical water absorbing polymer has water absorbency of 100 to 300 times than its own weight. So what are the applications of water absorbing polymers? Recent researches are focusing on the application of these polymers in maintenance of green infrastructures, optimization.
Abhishek, your screen is not moving. Is it?
But it is working here.
The slides,
Okay.
is it the slides are changing?
Yeah, in my desktop it is changing.
Here it's not changing. First screen remains as it is.
Maybe share entire screen, then it may help.
Okay. Let me check.
Now it is.
Yes.
Now it is working.
Yes.
It is better now.
Yes,
Okay,
correct now.
so the applications, recent researches are focusing on the application of this water absorbing polymer in maintenance of green infrastructure, optimization of irrigation water, bioengineered slope stability, reforestation, and arid land agriculture. So what it does when we mix the water absorbing polymer in soil, it absorbs the rainwater or irrigation water, and it swells in the swells and becomes gel type of material. So it one way it restricts the migration of water into deeper layer and retain nutrient within the soil plant root zone, and when during the evaporation it slowly releases the water held within the polymer structure, and so that the plant can grow in arid humid also in dry weather. So to check the effectiveness of this polymer in above applications, continuous field monitoring of volumetric water content is necessary, but the direct measurement of volumetric water content is not suitable for field monitoring. In such cases, indirect measurements using neutron probes or other electromagnetic sensors are always preferable. So most of the electromagnetic sensors work on the concept of this electromagnetic wave propagation, and it measures soil properties like dielectric permittivity and electrical conductivity, and then relate it with the soil volumetric water content. So the accuracy of these sensors largely depends on the manufacturer calibration, which needs to be validated before using it in field for any specific materials. So the for field monitoring of volumetric water content in WAP amended soil. And we also want to evaluate the influence of different polymer concentration on the performance of the sensor. So we have selected two different one soil. This is the soil is collected from the Brahmaputra river, and the main particle size, main constituent of the soil is sandy soil, and it is non-plastic in nature. So the purpose of selecting a non-plastic soil is it is reported in the literature that the performance of the polymer is best suitable for cohesionless soils. So that's why we have taken a cohesionless soils, and we have used a potassium polyacrylate water absorbing polymer, and its primary functional groups are analyzed using FTIR, and it is hydroxyl and carboxyl, and the water absorbing capacity is around 282 gram per gram in distilled water. Then we have developed this setup. We have taken a PVC column, and we place the bare soil and as well as the amended soil in three different concentration of polymer, 0.1%, 0.2%, and 0.4%. And we measured the water content using the sensors. Then we have taken out the top soil and extruded the sample, and the volumetric water content was evaluated using the oven dried method. So for evaluating the volumetric water content, we measured the gravimetric water content and the dry density of the soil. Now, the measured dielectric permittivity and the sensor measured volumetric water content is presented here.
You crossed 7 minutes, but how long will it take?
Sir, it will take around 5 minutes more.
5 minutes more?
Yes, sir.
You started with promise that you will finish in 6 minutes. But you finished in 2 minutes quickly. Huh? Too much information is not in.
Okay, so we have found out that this measured volumetric water content is almost 1.5 times than the almost less the sensor underestimates the volumetric water content because the water inside the polymer is bound water, not a free water. So this causes the dielectric permeability loss, and you can see that at a same water content, the bare soil gives more dielectric permittivity as compared to the polymer amended soil. So we have calibrated the value with the TOPS equation, and we have fitted the measured data point with a polynomial equation to obtain these parameters for calculating the volumetric water content. And there are linear calibration. We have also used a linear calibration equation. In that, we are directly fitting the measured volumetric water content and the accurate volumetric water content. And we found that all of the lines are passing through the intercept value is 0. So the slope can be termed as a correction factor, which need to be multiplied with the measured volumetric water content to get the accurate volumetric water content. And this correction factor is dependent on water absorbing polymer concentration. And with this equation, we can easily calculate the correction factor, which need to be multiplied with the sensor measured value to obtain the actual result. And this equation is valid for only for sandy soils. So my conclusion is the electromagnetic sensor underestimates the volumetric water content in WAP amended soil, and the error in measured volumetric water content increases with increasing polymer concentration. So we have used two material specific calibration equation, and we found that linear calibration approach is more simple, and it can be extended for a wide range of soil texture to obtain a generalized relationship to calculate the correction factor, which need to be multiplied with the sensor data to get the actual water content in the field. And these are the references. Thank you.
We'll not go for discussion right now. So at the end, if we have some time, if we get some time, we'll try to discuss. And now I'll go to next presenter, that is paper number 7. And the author is Susmita RT at Bindu. Is the authors, or any of the authors are there? Paper number 7. Effect of biochar for the remediation of heavy metals contaminated industrial site soil by Susmita or Bindu. Anyone is present? No, then I'll go to the next paper. This is paper number 8. So this is compressive strength of high plastic clay stabilized with fly ash based geopolymer and its synthesis parameters by Neeraj Verma, Tulsi Kumar, and Bamsi Nagaraju. Is any of the authors?
Yes, sir, we are here.
Okay.
Yes,
please,
sir.
Please try to highlight your work. Too much introduction is not required. You know,
Okay, sir.
a short time. Okay.
Okay, sir. Sir, is it visible? Hello.
No, not yet.
Sir, is it visible?
Not visible.
Okay. Sir, is it
Yes.
visible now?
Yes, yes.
Sir, my topic is on compressive strength of high plastic stabilized clay with fly ash based geopolymer and its synthesis parameters. My name is Neeraj Verma, PhD scholar from Department of Civil Engineering, Roorkela. And this is the and coming to the geopolymerization, it is a three-dimensional polymer network which have amorphous or semi-crystalline structure. We can use any material for synthesis of geopolymer material which have high amount of silica and alumina, and it requires some alkaline environment. And coming to the procedure required for geopolymerization, when we add this silica and alumina rich material in alkaline solution, silica and alumina tetrahedral units get separated from the rest of the raw material, and then after, with the help of oxygen atom, they are going to share silica and alumina atoms. Likewise, they are going to form a polymer network, and slowly the polymer chain will get polycondensate, and finally we have an amorphous or semi-crystalline structure. It is similar to the zeolite, but only difference is it does not go up to the crystalline. It is only and with amorphous or semi-crystalline material. Here, the raw materials used are high plastic clay collected from Guntur and classic fly ash from Vijayawada, and alkaline solutions are sodium hydroxide and sodium silicate, and mixed proportions are these are the mixed 8 molar NaOH solution, and so in the sodium hydroxide sodium silicate proportion mix ratio is 40:60, and fly ash is varied by 10, 20, and 30% by dry weight of soil, and proportion of liquid activator is 5, 10, and 15% with respect to the soil fly ash mix. And these are the index and engineering properties of soil, collected soil. It contains more fines up to 99%. Then after, the liquid limit is also very high, and as per IS soil classification system, it is classified as clay with high plasticity. And this is the chemical composition of fly ash. It has high silica component and alumina component, so it is suitable for geopolymerization synthesis. And its calcium content is very less, hence it is classified as class of fly ash as per ASTM classification system. And these are the sample preparation First, we are dry mixing of fly ash and soil. Then after adding alkaline solution, then after wet mixing until we are getting a homogeneous mixture. Then after preparing a cylindrical sample with an aspect ratio of 2:1. Then after, to avoid the moisture variations during the curing period, we wrapped in polythene covers. Then after we have cured, and after the particular curing period, we went for UCS testing. And two curing environments are taken. One is ambient temperature for 3, 7, and 28 days, and other at 50 degrees centigrade for 1, 3, and 7 days. And these are the results of curing time. With increase in curing days, the temperature is the strength of the soil will get increased. This is due to the polycondensation which we have discussed earlier needs some time to get a well-developed network. So with respect to with increase in the liquid activator content, so with increase in the alkaline content, the more silica and alumina are get dissolved, so that a well-established formula structure is going to take place, and the strength of the soil is going to get increased. However, with increase in the with increase in the fly ash content also, more silica is available, and so silica and alumina is available, so that we are able to get a higher strength at higher contents of fly ash and liquid activator content. And with respect to the temperature, with increase in the temperature, the enhancement in the geopolymerization takes place, and finally the final strength is going to be increases. And this is the comparison between the ambient temperature and at elevated temperature. If you check these, when we compare the normal temperature curing at normal temperature, the elevated temperature is showing the higher values. This is due to the acceleration of silica and alumina, dissolution of silica and alumina at higher temperatures, mainly for fly ash content. And now, with respect to the effect of molar ratios, with increase in the for the same fly ash content, with increase in the liquid activator, the sodium by alumina ratio is going to be increases. But with increase in the fly ash content for same liquid ratio, it is going to reduces because the alumina content is increases. So the ratio is going to get reduced. And here, with respect to the at peak values, we are getting the peak values for sodium by alumina ratio around 1, and for silica by alumina ratio it should be greater than 2 or in and around 2. So these are well satisfied with the literature work. And now the last part is the statistical analysis. Here we consider a simple linear equation. Here y is the dependent variable, and alpha and beta are the independent variables, and x0, x1, x2 are the coefficient. And here y is nothing but the compression strength, and alpha is the fly ash content, and beta is the liquid content. And after conducting the simple linear regression analysis, these are the coefficients we have obtained. And this linear regression analysis has done differently for different curing period and for different temperature. And this is the ANOVA test results. So from this we can see up to 7 days the p values are satisfying the 95% confidence level, but for prolonged periods of 14 days and 28 days, or for at high elevated temperature, the p values are not satisfying the 95% of confidence level. Those values are greater than 0.05 value. So we can suggest that the linear analysis is applicable only up to 7 days of curing, and it is not applicable for a prolonged period. For that one, we need multiple linear regression analysis or some few advanced techniques. And from these are conclusions we have drawn out. And always the strength is going to be increases with increase in the temperature time. And at 7 days curing, the UCS value at 50 degrees is very high, and it is almost greater than, it is 2.56 times. And well, compared to the 7 days and 28 days compressive strength at 27 degrees and at 50 degrees, the strength is almost 1.21 times higher. And similarly, the last one, and the linear regression analysis are sufficient only for the initial curing period at ambient temperatures only. For prolonged period, we need nonlinear or advanced techniques. And these are few references. Thank you.
Thank you for your nice presentation and within time also. So
Sir, thank you.
go to the next paper actually. So this will be paper number 9, numerical analysis on the reinforced earth wall backfilled with coal gangu by Chetan B, Muhammad A. Ashaq, and Hiralal M. So any of the authors present? Paper number 9? No, I hope. So paper number 10, study on retention characteristics of amended clay liner by Onjas and Ajit R. I hope authors are there. I could see Ajita is there. Or paper number 10. Hello. Paper number 10. Paper number 10 also not there. The Anju S or Ajit AR. So paper number 14 then, an experimental study on fly ash behavior landfill by King Shuk Da. King Shuk is there, I hope.
Yes, I'm here.
Okay, please join quickly. Huh?
Okay.
Take 5-6 minutes. Try to highlight your findings.
Okay. Is it visible?
Yes, coming.
Okay, thank you. Now, good afternoon to everybody. Myself, Kingshuk Dan from Kuchbehar Government Engineering College, West Bengal. And today my topic is an experimental study on fly ash behavior as landfill. Now, fly ash is an industrial waste generating in thermal power station. It is the finer fraction of coal ash, and it is the main problem is the disposal and handling of fly ash. So large scale utilization of fly ash is very necessary due to high ash contents of coal, Indian coal. So it is observed that among different uses of fly ash, the large quantity of fly ash is used in different geotechnical areas. Fly ash can be used as a construction materials for the embankments, and it can be used as a landfill material in shallow water. And as we know, the fly ash is a clay seal type in nature, so it can be similar to fine grained soil, which can be employed effectively as fill material. And if adequate sand is mixed with it, then its strength can be enhanced. Now, in this study, it is attempted to investigate the use of fly ash as landfill material under shallow water, and the series of experiments are carried out to investigate the settlement, dry density, and water content behavior of fly ash and fly ash mixed with sand layers, and also the effect of characteristics of the fly ash when compaction and compacting effort are there, and the strength characteristics are also investigated. Now, there are so many papers are there regarding this. First of all, I have already told that fly ash is a fine grained material. So to understand the settlement behavior of fly ash, it is necessary to understand the settlement behavior of fine grained soil. So in this respect, IMAI in 1980 classified the settlement behavior of fine grained soil into 4 categories, that is dispersed, flocculate, zone, and consolidation settling. And these are elaborated by Sridharan Prakash in 1997. From their study, it is observed that the dependence of these different kinds of behavior of consolidation behavior or the settlement behavior depends on the clay mineral type and initial water content. With less water content, the consolidation settling is there. In 1995, proposed method where the using of the adequate sand can enhance the strength characteristics as well as the settlement behavior of the fly ash. So now again, there are different papers are there. Gupta 1999, Kim et al. In 2005, and so many papers are there where we can get the informative study, where we can get the information of uses of fly ash in different geotechnical areas and their advantages, some limitations, the challenges. So lots of papers are reported in the literatures, but we have I have enlisted some of these here. Okay. Now I will concentrate, or I will focus on my study. The two series of experiments have been done here, where three kind of cylinders are used with different diameters, that is 71.4 millimeter diameter, 200 millimeter, and 298.5 millimeter diameter. In first series of experiments, all three kinds of cylinders are used, and for each cylinder, we have conducted three tests with using fly ash with 10% sand and fly ash with 20% sand. For cylinder 1 and 2, we have done extra test, which is done with using fly ash after shaking, where it is attempted to see the behavior of settlement behavior of fly ash or the dry density and water content profile of fly ash after it is allowed, after it is flowing with high forces. Now, what is how it is done? Suppose for cylinder 1, the first layer of fly ash is poured. At first, there is a water height of for cylinder 1, it is 125 millimeter. Then first layer of fly ash is poured, which is about 250 gram. Then it is allowed to settle. After some time, it is beginning to settle, and clear interface is shown. And if time settlement curve is we can draw time settlement curve, then it is very visible that it takes nearly 4 hours to completely settle it. That means full settlement is there after 4 hours. So we allow it to settle for 4 hours. When fly ash is used with 10% sand, then at first we pour fly ash for 225 gram, then 25 gram of sand is used, and it is allowed to settle for another 1 hour. Okay, then it is after completely settlements for cylinder 1 and cylinder 2, we have used 4 layers, and after removing after complete settlement, then we have taken the dry density and water content data. Then after completion of the full settlement, then we have to remove it, and we remove the each layer. We remove it layer by layer. And for cylinder 1, cylinder 2, we have remove it by 4 layers, and cylinder 3, we remove it in 7 layers. And for each layer, we have taken the weight and thickness of the layer, by which you can get the bulk density and dry density. And water content is measured from the mid height of the layer. Now for series B, the similar kind of tests have been done. For here only cylinder 2 and cylinder 3 are used, and for cylinder 3 extra tests have been done with using compaction pressure with 0.2 kg per square semi and 0.5 kg per square semi for cylinder 2 and 3, and for cylinder 3 only 0.2 kg per square semi. And here the dead weight are used, which is kept for about 24 hours to get the effect of compaction pressure. This is a schematic diagram I have shown here. Now from the test result, you can see fly ash is mainly silty type in nature. The 75% of particle in between 2 microns to 75 microns, and specific gravity test, Atterberg limit test, and Proctor compaction task tests are also done. The maximum dry density is observed as 1.158 gram per cc, while optimum moisture content comes out as 32%. And simultaneously, grain size distribution of the sand, which is used also, that is also done here. And you can see the different percentage of the sand is there. And from grain size distribution, we have calculated the uniformity coefficient and effective diameter values. This is the settlement behavior. You can see the in y-axis it is height of interface, and in the x-axis it is time. And this is for cylinder 1. You can see the after 15 minutes, the settlement is initially settlement is uniform, but after 15 minutes settlement is reduced, rate of settlement is reduced, and after 30 minutes settlement is already asymptotic, and it is clearly seen here. Okay, the similar kind of the settlement behavior is observed in cylinder 2 and cylinder 3. Here sharp interface is shown, a sharp interface is observed. That is, we can see that the zone settlement is happening here. For cylinder 2 and cylinder 3, after 8 to 10 minutes, the settlement rate is reduced.
So try to finish in 1 minute.
Okay. Now this is dry density water content behavior. From dry density behavior, we can see with addition of the sand, there is an increase of the dry density, and there is a decrease of the water content. This is because when the add sand is mixed, the lateral there will be the drainage length is reduced, and there will be a chance of lateral drainage. That is water content is reduced, and when shaking is happening, there the dry density is increased and water content is reduced. For cylinder 2 and cylinder 3, for the upper layer, this difference of dry density or improvement of dry density is not so much prominent. But for cylinder 1, we can see there is an appreciable increase of the dry density in the dry density for upper and lower layer also. This is the effect of compaction pressure. You can see in upper layer and lower layer there is an increase of the dry density dry density for both cylinder 1 and 2 due to the mixture of sand, and in upper layer also this increase of the dry density is very appreciable. But in the bottom layer, this is not as much as the upper layer, but we can see there is a increase of the dry density. So compaction pressure giving good results to increase the dry density. Both cases we can see it is generally 20% increase in upper layer for cylinder 2 and 10 to 17% for the cylinder 3. Now strength from shear strength test we have done, and it is done with different maximum density and different water content. We get C and phi value, and from these values we can utilize to estimate the shear strength of sedimented fly ash and fly ash mixed with sand by interpolation process, and these results are shown here. And you can see from data, this is cylinder 3 data, that with compaction the C and phi value, that means the strength parameters are increased, that means the strength behavior is enhanced. Whereas when we mix with sand, the similar kind of results are available. Now these are discussed, whatever I have discussed, these are shown here. With the mixture of sand and with compaction pressure, the density behavior is enhanced, and shear strength parameter, there is a increase of shear strength parameters. These are conclusions, and we can finally conclude that the fly ash can be effectively used as a landfill material under shallow water, and when sufficient amount of the sand is mixed, then when sand layer is placed in between two successive fly ash layers, then we can increase the dry density as well as the shear strength. So that is my conclusion.
Okay, thank you. Because we have shortage of time, so we'll move fast to the next paper. Next paper, I think author is ready. I think it is paper number 15. Geotechnical characteristics of thermal power tech fly ash from Krishnapatnam, Nellore by Narasimha Rao, BND, and Binoy Kumar P. I think authors are present here.
Yes, sir. Good evening, all of you. I am audible?
Yeah. Okay. Please join. Please quickly highlight your objective and final outcome.
Yes, sir.
Too much detail.
Sure, sir. First of all, let me thank IGS for giving me this opportunity to present my research on geotechnical characteristics of thermal power tech fly ash from Krishnapatnam, Nellore. This is part of UGC minor research project to find the geotechnical characteristics of 6 fly ash samples from 6 thermal power plants in Andhra Pradesh. We are all aware that fly ash is a major problematic solid waste, and the scope for bulk utilization of fly ash is in geotechnical engineering applications. So that's why this study. So we are burning 1,000 million tons of coal to power our world, and fly ash is the fine powder collected from combustion gases of coal-fueled power plants. And typically, we have fly ash to bottom ash in the ratio of 70 to 30. In different type of boilers, it may vary. And India tops in the production of fly ash as a solid waste. These figures are from 2005. And there are disposal problems. The annual generation of fly ash is increasing from 112 million tons per annum in 2005 to approximately 270 million tons as on today. And this required a huge area for disposal of the fly ash, that is the pond ash area, which increased by more than 3.5 times from 265 square kilometers in 2005 to 1,000 square kilometers in 2015. So this is causing pollution of land and water. And the utilization of fly ash, India is one of the lowest, 38% utilized. Of course, these figures are from 2005. And fly ash is used in different purposes, but there is a lot of scope for utilization in geotechnical applications. The Ministry of Environment and Forest has given notifications to utilize 100% of fly ash for within existing power plants within 15 years and new power plants within 9 years. This notification came in 1999. This target is far from being achieved. There is a lot of scope for utilization of fly ash in geotechnical engineering applications. It has not only engineering benefits, that is, we can save soil from erosion in the utilization, and that is and the economic benefits are also there because it's basically a solid waste and coupled with ecological benefits. The question is the uniformity of the fly ash obtained from different thermal power plants, because the characteristics can change with the type of coal which is used, because in every power plant both domestic and also imported coals are used. These depending on the availability, the quality of the fly ash that is produced will vary, and also depending on the power required at the boiler, the extent of grinding also varies, and that's how the characteristics of fly ash vary from within the plant and also from plant to plant. And this necessitates to characterize the fly ash from different power plants. That's why this research project has been taken up. And this knowledge of geotechnical characteristics of fly ash definitely enhances the awareness among the engineers, and which ultimately promotes bulk utilization. And these are the different thermal power plants in Andhra Pradesh. Their capacity in million watts varying from 1040 to 2000 million tons. And the fly ash generation is also given over here. And the one shown in the red color, the Thermal Power Corporation Limited, Thermal Power Tech Corporation Limited, it was actually taken over by Semcog Energy India Limited, Phase 1, Singapore. The fly ash is basically low calcium fly ash, and this is some of the literature, earlier studies that have been carried out for determination of fly ash. And this plant, Thermal Power Tech Corporation, was established in the year 2015 and was taken over by SEIL Singapore, as I mentioned. The quantity of fly ash produced is 1.5 million tons per annum. Although there is a lot of export of fly ash to Middle East, but still 100% is not being utilized in this whatsoever. So coming to the materials and methods, this is the fly ash which was collected from the plant, and commercially available lime and also Recron 3S polyester fibers have been used for stabilizing the fly ash to improve the properties such as CBR. These are the characteristics of the polyester fiber that has been used in the study. The laboratory studies of the fly ash without adding any admixtures and also after addition of admixtures have been carried out, which includes grain size analysis, including hydrometer analysis, because major portion of the fly ash is fine material. Heavy compaction, shear parameters using direct shear test, CBR, permeability have been determined. The shear parameters, CBR and permeability have been tests have been conducted at heavy compaction. And not only this, the XRD, the scanning electron microscope and FTIR analysis has also been carried out. The specific surface of the fly ash is also determined using the Blaine's air permeability apparatus. So this is the grain size distribution of the fly ash. You can observe that 79.7% of the total fly ash sample is silt. So the problem is fly ash has some liquid limit you can find out, but fly ash is basically non-plastic. So with such a large fine content, there is no, it does not fit into the classification system of the ISR, Unified Soil Classification System. Therefore, Prakash and Sridharan has developed a different type of classification for fly ash. So if the core silt size fraction is more than 50% of the fines, that is of the size 20 to 75 micron, it is classified as low compressible non-plastic silt. And the present fly ash sample comes under this category, classified as non-plastic low compressible silt designated by the symbol MLM. And this is the X-ray diffraction pattern. The quartz is indicated by the very strong peak at 2 theta angle of 26.9, and other peaks are also there. Mullite is also indicated by this particular strong peak at 41.08 2 theta angle and other peaks. And these are the scanning electron micrographs at different resolution. This is 20 microns, this is 10, this is 5, and this is 2 microns. So this micrographs will reveal that most of the particles are spherical in shape. And this is the FTIR spectrum of the fly ash sample. The main absorption band of the vacillation oscillations of SiO, Si groups, actually it is in quartz. It is indicated by 1089 absorption band.
We're not hearing. Is there any problem? All are hearing? I am not.
No, we can't hear you.
Okay. So perhaps it is almost towards the end, but I don't know whether should we wait or we'll go to the next. But he has to come out. I think we can go to the next. Is it okay?
I think yes, sir. We can move to next.
We move to next. Okay. So
It's better to move.
Yeah. Next presentation is paper number 16, treatment of alkaline dredged material with lime by Abhijit A. and Joabi. So I think authors are here.
Yes, sir.
Yeah. Okay. Please join quickly.
Okay.
And take around 5 minutes.
Yeah, sir. I will try to finish it as soon as possible. So, is my screen visible?
Yeah, screen visible.
Okay. So, good evening, everyone. So, the topic is treatment of alkaline soil with lime. Myself, Abhijit. And let's move on to the overview. This is the overview. And the introduction. Alkaline Valley Lake is one of the oldest tourist spot in Thiruvananthapuram, and it was famous for its scenic beauty. And it was about 1 kilometer square in area and fed by 2 streams. But now, because of rapid urbanization and reckless waste disposal, these streams, along with the canal called TS Canal, which is one of the most polluted canal in the city, act as conduit for pollutants and significantly contribute to the heavy metal burden of the lake. And now Akalam Lake has been listed as a hazardous site with the presence of heavy metals in its sediments. So as a part of reviving it, Kerala government is actually doing some dredging activity in it, but the dredged soil doesn't have a proper disposal system, thereby it is affecting all ecosystem components, including aquatic and terrestrial systems. So the heavy metals from dumped dredged material migrate from the soil and contaminate the groundwater. So we know that once a metal has contaminated the soil, it will remain as a threat to environment until it is removed or immobilized. Thus, the study emphasized on determining the contamination in Akullam dredged soils, also examining the effect of lime as it how effective it is in immobilizing these contaminants, and in the end a beneficial use of lime treated soil on pavement and its impact on groundwater is analyzed. So these are some of the literature review. I'll skip through this. And coming to the methodology, initially the dredged material is connected and it is subjected to various geotechnical testing, and the heavy metals are determined using X-ray fluorescence spectrometer. Then a lime is added to it on varying content, and a set of 6 treated samples is occurred. And on both the treated and untreated samples, several colon leach tests were conducted. Then the effluents were collected continuously for 13 days, and it was subjected to atomic absorption spectrometer to determine the concentration of these metals in the leachate. On the other hand, you can see the strength and compaction characteristics of the soil on the addition of lime was also analyzed. So based on the UCS value and the immobilization efficiency that was calculated from the colon leach test, an optimum lime content was found out. So for this optimized sample, CBR was checked just to make sure that it could be beneficially used for used as a treated dredged material in pavement. So in the end, numerical and simulation to study the groundwater impact using a software called WISLEACH, which is based on advection dispersion reaction equation, was used. Now, moving on to the result, the geotechnical properties of the dredged material is listed as here, and here is the Akullam dredged site. So the soil has been classified as highly compressible silt as per the IS classification, and the pH is about 3.55, which is really acidic. So looking onto the chemical constituent, we can see the major content is silica, and alumina is about 25%, and there is a considerable amount of ferric iron as well. But when you see at the heavy metal contamination, as per the US EPA standard and sedimental guidelines by US, we can see the soil is heavily contaminated with nickel and lead, whereas it is moderately contaminated by zinc. Now, as I mentioned, lime is added as the additive. So in order to lime to achieve the Bosonic reaction, the pH should be hiked to 11.5. So you can see by adding more than 6% lime, we can hike it to 11.5. So the lime content was varied like that, and the compaction curve is like this. So you can see as on increase of lime content, the maximum dry density is found to be decreasing, whereas the moisture content is found to be increasing on the addition of lime. Now, moving on to the UCS sample. So as lime is increased, the unconfined strength was also found to be increasing, but you can see for 10% lime had the maximum, thereby the optimum lime content is taken as 10%. When you also look at the immobilization efficiency of several contaminants, that was lead and nickel, you can see for 10% the maximum efficiency was achieved at 82%, whereas in the case of nickel, it was found that on further increase of lime content beyond 10, the immobilization efficiency was also found to be increasing. And it should be noted that the 10% lime mix also had a CBR improvement of about 6.13. So which is greater than 5, thereby as per IRC, we can use it as, we can beneficially use it in subgrade material. So as a conceptual model, a conceptual model was developed using a software called WISLEACH with a typical highway section, utilizing the stabilized dredge material above the subgrade, in this layout. And the properties and dimensions were all taken as the default value from the software itself. So the groundwater table was assumed to be 6 meter, and the average rainfall was taken as 2000 mm per year. The concentration of nickel and lead from the 10% treated leachate columns were fed as input into the model to predict the contour concentration map of the contaminants at several time intervals. So here we can see the contour maps, and this is the concentration contours of lead leaching from this stabilized layer over here for different several years. And our concern is regarding when it reaches here and what is the concentration. So we can see after about 8 years, it reaches the groundwater, and on reaching the groundwater, its concentration is really less when compared to the drinking water standard. And similar in case of nickel, it reached the groundwater by about 4 years, and the concentration is way less than drinking water standard. Thus, it is actually safe. So as conclusion, we can say that Aquiline rich material is categorized as heavily polluted soil in terms of lead and nickel. The optimum lime content was found to be 10 to 12% with respect to the unconfined compressive strength. And on 7th day, we could see that the unconfined compressive strength surpassed a value of about 350 kilopascal, which is actually a regulatory waste disposal limit set by US EPA for in-situ stabilization. So that was also reached. And lime treatment showed that a maximum immobilization efficiency of lead at 82% could be achieved by about 10% lime, and for nickel, 67% of immobilization could be achieved by 12% lime. So for the optimum lime treated, the CBR value inferred that it could be used as subgrade fill, and the predicted contour inferred that heavy metals from the conceptual model will only reach the groundwater at 6 meter depth after approximately 4 years, and by that time the concentrations are below the drinking water standards set by WHO and also IS standards. So these are the important reference of the paper, and thank you. Hello.
Hello, Abhijit. I think it is okay. Professor Dilip, Sabadia. Okay, maybe we can move to next presentation.
I think the net connectivity has gone. I'm Dr.
Hello. Hello, can you hear me?
Dr. Ankit, you are audible. Please go ahead.
Yeah, okay. So we will move to next presentation. It's a study on characteristics of overburden dump of coal mines by Atul Gautam and Yadu LK.
Thank you very much, sir.
Correct. So my mic was mute actually. Sorry. Sorry. Please.
Very good evening, sir.
Yeah.
Am I audible, sir?
Yes.
Okay. So, very good evening to Dr. D.K. Vaidya, sir, Dr. Ankit Dutt, sir, and Dr. D. Nimya, ma'am. And thanks for allowing me to give presentation on topic study on the characteristics of overburden dump of the coal mines. And I assure you that I will complete within 4 minutes. I've deleted many slides. So once again, very good evening to all. Sir, am I audible? Can I proceed? Okay, thank you, sir. So nowadays, open cast mining is done dominantly all over the world. During these mining operations, huge amount of overburden dump is generated. In present case, study is done from this aspect at Singoli Mines near Khaparkeda under administrative control of Western Coalfield Limited. This mine is situated in Nagpur near Khaparkeda. The presence of dump has led to situation where useful land is wasted, and also the properties of dump are also not fully vested. So the overburden dump upon excavation from the open cast mine will lead to the problem of loss of fertility. Hence, the study is done on this aspect. The presence of dump has led to situation where useful land is wasted and the properties of the dump are also not fruitfully invested. These has led to huge waste in the captive area. For any implementation of material in the construction or otherwise, the characteristic determination is inevitable, and thus this study deals into the realm of physical and chemical analysis of the overburden dump of these coal mines. So in present case, these are the project details. Total mine life is 17 years. Volume of OB is 66.73 mm cube. Total project land is around 426 hectares. Duration for extraction is 50 months, and stripping ratio is 1:7.6. This is location of Singori mines, and figure. This is photograph of the collected OB sample overburden dump. So following tests we have carried out on the OB material: CF analysis, these geotechnical properties, CF analysis, specific gravity, turbidity limits, Proctor test, permeability, direct shear test, consolidation test, and free soil index. And these are the results. At present, we have selected 4 samples, and these are the geotechnical properties of the material collected from the site. These are the photographs taken during the testing in laboratory. We have conducted Proctor test also to determine the OMC and MDD. We have conducted free soil index test on the OB material. We have determined gravel, sand, silt, clay of this OB, and also specific gravity test. So we have also conducted a test on the pond ash. This pond ash sample is collected from NTPC Mauda, which is approximately 40 kilometers from Nagpur, and we have determined all these geotechnical properties of the material collected from this site. Then result, based on the material characteristics of sample collected from mines, it has been observed that OB material satisfied the requirement of pond ash as per the requirement of IRC 58/2001 table number 1. Basically, this OB material is just similar, it satisfies all the requirement of this pond ash, and hence it is recommended that this OB material, whose management is a big challenge for the mining industry, can be effectively utilized. And also we have proposed this solution to the WCL officers, and soon they will utilize this pond ash into the construction activity. But before this, we are doing other trials also. We are trying to utilize this material by adding some industrial waste also. But all this process is under the documentation is under the process, and we are getting positive response from the officers of the Western Coalfield Limited, Civil Line, Nagpur. Then following conclusion can be drawn from the test result. After proper trial analysis, this overburden material can be used in the combination with locally available marginal material. So here we are planning to do more trials of this overburden material with fly ash, so that we can use it more effectively in the highway construction and embankment also. The OB material can be utilized as soil stabilizer or filling material. Other environmental problem and that possible mitigations can be proposed to the mining authorities during further research work of the overburden dump. And this research may lead to use of byproducts, suitability of the proposed material as the construction material, reduction in environmental hazards due to dumping. And these are the references. And once again, thank you very much, and very good evening to all the respected.
Okay, thank you. Actually, previous speaker, there was a question in the chat box. If you can reply, it will be good there, because that time I have also mentioned, but the mic was mute. So let us move to next presentation. It is paper number 23, effectiveness of bioremediation technique on oil contaminated marine soil by Shrabha K, Sangita S, and Hari Krishna P. Is there any of the authors present?
Yes, sir. Present, sir.
Okay. Please join quickly.
Sir, sorry for interruption.
Yes,
but question in previous presentation.
In the previous speaker, there was a question in the chat box. The contamination. What is the source of contamination? You can just, if you can, reply to that, it will be good.
In that mining area.
No, not mining. It is a previous speaker actually, just before this one.
Okay, which one? Sample was collected from Kerala.
Yeah.
Okay, sir. Okay, thank you very much.
Sorry for
Okay, joining. Sir,
is my screen visible, sir? Sir, is my screen visible?
Yes, visible.
Yes. Good evening, everyone. My name is Shravya. I'm here to present a topic under effectiveness of bioremediation technique on marine soils. And following are my contents, which I'm going to discuss now: introduction, methodology, objectives and results, and concluding remarks and references. Coming to introduction, my major portion of contaminants are from municipal waste, sewage, and industrial waste, which has been where soil has been contaminated. These contaminants can be either be treated with physical, chemical, and biological methods. In these in remediation process, temperature plays a major role in degrading naturally. Degradation of hydrocarbons differs in soil and aquatic environment. Coming to bioremediation, it uses microorganisms for removal of any type of contaminant from nature, such as oil, water, and in soil, either in aerobic and anaerobic condition. This is called as bioremediation. Coming to objectives, to find the effectiveness, to find the influence of contaminants on properties of soil, and to find the effectiveness of bioremediation in removal of oil contaminant, and how with the suitable nutrients for bacterial growth. Coming to methodology, soil sample has been collected from Visakhapatnam, RK Beach, and the soil is oven dried for 24 hours at 100 degrees Celsius. And index and engineering properties were found for contaminated and uncontaminated soils. Later on, artificially, the soil is being contaminated used engine oil, and bacteria is added, and endosperms of bacteria is added, and nutrients are provided for them. After treatment, FTR analysis were performed for contaminated soils, and percentage of degradation was found out. Proportions of that contaminant that was used for soil samples were 3 kg of sample was used, and 300 ml of used engine oil was used for 3 kg of each sample, and 500 ml of water is added to maintain optimum moisture moisture content. Bacteria used are endospores of endospores of bacteria were diluted in 100 ml of water, and nutrients provided are 10 grams of NPK and 10 grams of organic fertilizer. Here are the combinations used for this study. And soil plus oil is kept as a reference. These are the combinations with soil plus oil. BTI and BTK are the endospores which I have used. BTI is Bacillus thuringiensis and Bacillus thuringiensis kurustaki, and NPK fertilizer with organic, with both 4 combinations. Here are the general parameters which are used for untreated sample. Like results are specific gravity got 2.61, and the soil is classified as poorly graded sand, and optimum moisture content 8%, and maximum dry density is 1.64 gram per cc. Coming to properties of both contaminated and uncontaminated soil samples, phi is 31 degrees and for uncontaminated soil before treatment, and contaminated is 22%, because it has been reduced with 29% with uncontaminated soil. Coming to cohesion, it has been increased, and pH it has been decreased. Electrical conductivity it has been decreased because due to the presence of polar nature, and chlorides has been increased. This is a grain size distribution curve, which is for untreated sample, and compaction curve to determine the maximum titer density and OMC. And this is a graph for untreated and for uncontaminated and contaminated soils. Later on, the FTIR spectrum was found out for reference sample, which is kept with combination of soil plus oil. The treatment was done after 30 days. This is a spectrum of BTI species with organic fertilizer. These are the major peaks that has been found, and these soil treated with BTK species and organic fertilizer, and FTIR analysis for BTI species and NPK fertilizer. This is for BTK species and NPK fertilizer, and this is combination of comparing, keeping BTI species as common and comparing the fertilizers like NPK and organic fertilizer. This major red graph indicates the treatment without any soil plus oil combination without any treatment, which is kept as reference, and blue graph indicates the treatment with organic fertilizer, and black color indicates treatment with NPK fertilizer. Here comes to BTK species which are treated with NPK and organic fertilizer. Here comes the red graph indicates with treatment without any, which is the sample which is kept as reference, and blue color indicates organic fertilizer, and black color indicates NPK fertilizer. These are the peak absorbance for 5 different types of sample. The overall area of these 5 area of peaks are: for untreated sample 18.88 units, for BTI with NPK combination 5.3, BTI with organic 10 units, BTK with NPK 6.6, and BTK with organic is 14.6. Here comes the percentage of reduction with different bonds with respect to reference sample are. Major percent of reduction has been seen in BTI with NPK species. Coming to concluding remarks, NPK fertilizer has greater biodegradation process when compared to organic fertilizer, and BTI species has augmented with NPK fertilizer showed the best combination in treatment studied here. And overall percentage of reduction with NPK fertilizer is 72% with after the treatment of 30 days, and organic fertilizer shows slower degradation, and it is also a nutrient for greener solutions. Coming to references. Thank you, sir.
Thank you. So thank you for a quick presentation. Let me check now. Last 2 presenters, both are there. Both are present. Paper number 26 and 27. Biologically treated.
Yes, sir, I am present.
Okay, present. Soil as a landfill inner material. So you are present. And then last one, that decontamination of heavy metal, by Rajsekhar P and Somnath Mandal. Is there present? Okay, then you paper 26. Actually, Kavya, Kesh, and Ajita AR. So any of you, if there, please quickly join. Okay.
Hello, is the PPT visible, sir?
Yeah, yes, visible.
Okay, so the topic is microbially treated lateritic soil as a landfill liner material, and myself Kavya KS, PG student of College of Engineering Trivandrum, and my co-author is Professor Ajita Ayar, Department of Civil Engineering, College of Engineering Trivandrum.
Okay.
So the first of all, the topic that is microbiologically induced calcium carbonate precipitation. It is a biogeochemical process that induces calcium carbonate precipitation within the soil matrix due to the action of microorganisms present in soil. And there are several mechanisms through which the MICP can take place. One of the method is urea hydrolysis mechanism. And in this mechanism, what it happens is the bacterial cells which are negatively charged get attached to the soil particles, and these bacteria can cause hydrolysis of urea adding to the soil, and there happens breaking of urea into carbonate ions and ammonium ions, and then we will add a cementation solution, preferably calcium chloride, which contains Ca2 plus ions, and the bacteria cells attracts the Ca2 plus ions, and the Ca2 plus ions will further attract carbonate ions, thus causing calcium carbonate precipitation within the soil pores. So there are three methods of execution of MICP into soil, that is surface percolation, in which the bacterial solution and cementation solution is simply sprayed into the soil by keeping some interval between the spraying of two. In injection method, next is injection method, in which both the solutions are injected into soil. Next is premixing method, in which the bacterial solution is first premixed with the soil, and it is some time period is given so that the bacteria get attached to the soil particles, and then cementation solution is either injected or given by surface percolation method. So the effect of MICP on soil properties is that it can increase the unconfined compressive strength, shear strength, liquefaction resistance, and adsorption characteristics of soil, while it will reduce the permeability of soil. This Then the factors influencing MICP are that is temperature, bacterial concentration, pH, degree of saturation, and the concentration of cementation solution. Study is conducted to develop a landfill liner material out of lateritic soil treated with MICP technique, and as a preliminary study, an effort was made to find the effect of MICP treatment on the hydraulic conductivity of lateritic soil. So this is the requirements of soil liner material as recommended by Environmental Protection Agency Guidelines 2013, and these guidelines guided for the selection of soil for the study. So next, the materials used for the study was, first is lateritic soil, which was collected from the College of Engineering Trivandrum campus as disturbed samples from a depth of 3 meters below ground level, and these are the properties of the soil collected. And okay. Then the next is the microorganisms used for the study was Bacillus megatherium, and it was obtained from MTCC Chandigarh, and the composition of nutrient broth used for the bacterial growth is shown in the table. The cementation reagent used is calcium chloride, and along with urea and nutrient broth, which would act as the nutrition for the growth of bacteria. So coming into methodology, first step is to treatment of lateritic soil by three different methods, that is injection, surface percolation, and premixing method, so as to find out the best method of execution of MICP in lateritic soil. Then after finding the best method, then through that method the lateritic soil was treated, and by varying the concentration of bacterial solution, so as to find out the variation of hydraulic conductivity of soil with the change in concentration of bacterial solution. For the study, for oven-dried soil finer than 425 micron was taken, and the samples were prepared at optimum moisture content, and the molding water comprised of 1/3 of bacterial solution and cementation solution, and 1/3 of pore volume of soil was taken as bacterial solution and remaining as cementation solution. And in the first stage, the soil was treated through three different methods, in which the bacterial solution concentration was kept same, and a curing period of 7 days was given. And first is injection method, in which the solution was injected at a pressure of 20 kilopascal, and a rest period of 24 hours was given in between the injection of bacterial solution and cementation solution. Next is surface percolation method and premixing method. So coming into the results, first of all, determination of best method of execution of MICP in lateritic soil, and the hydraulic conductivity of soil was checked, and it was found that the hydraulic conductivity of soil reduced with the MICP treatment, and it was obtained least for soil treated by premixing method. The premixing method produce least permeability. So this may be because during premixing, calcium precipitation occurs uniformly in all soil voids, which leads to bioclogging. And in case of sample prepared through surface percolation method, what I had found is that there was no much reduction in permeability. This may be because of the compactive effort that cemented the soil to such an extent, which created a low infiltration rate of the bacterial solution into soil. So the hydraulic conductivity is the primary criterion adopted while in the design of a liner material, and hence premixing is assumed as the best method of MICP treatment in lateritic soil. Next is the effect of concentration of bacterial solution on hydraulic conductivity of soil, and the concentration of bacterial solution was varied like as shown in the table, and the permeability goes on reducing into the from the order of 10 raised to minus 5 centimeter per second to 10 raised to minus 7 centimeter per second. And this is because there is obviously a result in a reduction of permeability due to calcium precipitation occurring within the soil pores, and it is observed that laterite soil treated with a bacterial concentration of 18 into 10 raised to 8 CFU per milliliter provided a curing period of 1 month, possessed a hydraulic conductivity below 1 into 10 raised to minus 7 centimeter per second, which is the criteria given by EPA. So the concluding points are, out of the three methods, the best method is premixing for the treating lateritic soil through MICP method, and the hydraulic conductivity of soil lateritic soil reduces with increase in initial concentration of bacterial solution. And as already told, the soil treated with 18 in 10 raised to 8 CFU per milliliter of bacterial solution, providing a curing period of 1 month, satisfies the permeability criterion as given by EPA 2013. So these are the references. Thank you.
Thank you. So let me move to last presentation. By any chance, I did not get response. Rajsekhar P or Somnath Mandal is present here. I think good that helped us to finish little early. The last presenter looked like is not present. So I'll request our co-chairman Ankit quickly summarize the session so that we can join the AGM. And also in between, actually, there are some disturbance. We could not complete maybe 1 or 2 slides. We left Professor Tagaraj, also another presentation. I hope we cannot go back perhaps. So let us conclude the session. We'll discuss maybe some other time. Is it okay? So please.
Thank you, Professor. Yeah. Thank you, Professor Bedia, and also thank you, Dr. Nilima, for efforts in organizing this session.
Oh, sorry. Sorry, actually, this last presenter is there. They are coming. They, without responding, they are presenting, actually. Sorry. So let us hear. So they are entering. They are joining. Okay, please quickly. Who is presenting? Rajsekhar. Okay, hello. I am seeing the slide, but no response. Yes. Hello.
I think some audio issue from the speaker side, from the student side.
Could you hear us, Mr. Rajsekhar? Perhaps we will not be able to help him. What to do?
Sir, it is audible now, sir.
Is it audible?
Yes, sir. It is audible now, sir.
Yeah, Rajsekhar speaking.
Yes, sir. Yes, sir.
Okay. Quick.
Can
Please.
I start, sir?
Yes, we are hearing you.
It is okay, sir. Now it is visible, sir.
Yeah, visible. Yes.
Yes, sir. Very good. Yes, sir. Very good afternoon. Good evening, sir, to everyone. My name is Rajsekhar. I am a MTech scholar from NIT Jamshedpur.
Okay.
My presentation is decontamination of heavy metal contaminated soils by phytoremediation by part experimentation. These are the list of the contents I am discussing. Coming to the introduction, due to lack of industrialization, waste has been generated in very huge scale. In approximately 110 million mines and industrialization, other exploited of wars, 64 countries are releasing the waste, which is by 1.3 billion tons of municipal solid waste were generated around the world per year up to 2012. If we ignore this, it will increases up to 2.2 billion tons annually by 2025. If we ignore this is as a geotechnical engineer, we may not witness a very healthy soil from our mother earth. Coming to the phytoremediation. Phytoremediation is a sustainable technique for the removal of chemical contaminants, both organic as well as heavy metals, from the contaminated soil as well as water by green plants. Coming to the mechanism, there are 5 methods involved: rhizodegradation, phytodegradation, phytostabilization, phytoaccumulation, phytovolatilization. Coming to the rhizodegradation, the degradation of heavy metals contaminants may degrade in the root zone, rhizosphere zone. That is called rhizodegradation. Coming to the phytodegradation, in the plant tissues, the heavy metals may degrade. That is called phytodegradation. Phytostabilization means the heavy metals may get dissolved in harmless forms. That is called phytostabilization. Phytoaccumulation means that heavy metals may present in the plant tissues in fruit zone and the flower zone, in the leaf zone and stem portion, but it cannot be removed. That is all still exists in the plant species. That is called phytoaccumulation. Phytovolatilization means the heavy metals may volatilize through transpiration and volatilization process. That is called phytovolatilization. These are the from the literature review. These are the contaminant source may exist in the world. I have collected the soil sample and I have conducted the geotechnical soil test, and these are the properties of the soil, and classified it as low compressible clay soil, which is pH is 7.8. Coming to the research methodology, I have selected the 3 plant species based on the literature review, which I have still not done research on this: Setaria italica, Sesamum indicum, Vigna radiata, with one control part and 3 heavy metal contaminated parts. Coming to the concentration: cadmium, copper, zinc. Cadmium 150 milligrams per kg of soil, and copper 800 milligrams per kg of soil. Zinc 1000 milligrams per kg of soil. Coming to the preparation, I have added 15% of water content by weight of the soil. And based on this, I have added the 0.613 grams of cadmium chloride, like that cadmium chloride, copper sulfate and zinc sulfate are added. Coming to the results and discussion, first after sowing that seed germination I have been observed. Coming to the Setaria italica plant, the seed germination is better compared to other 2 plant species. Coming to the zinc contaminated soil, the germination percentage is almost good for Sesamum and Vigna radiata. Compared to the 2 plants, Setaria italica plant is showing higher percentage of germination. Coming to the cadmium contaminated soil, compared to Sesamum and Vigna radiata, Setaria italica plant is showing better germination. Percentage survival of plant species. percentage survival means how many plant species still alive to the how many percentage of how many plants are germinated. That is called percentage survival. Based on this, in control soil, 3 plant species have been survival is good, but in the coming to the contaminated soil, the only Setaria italica plant is showing good and Vigna radiata plant is showing good. Worst condition is Sesama indicum plant. Next, coming to the height of the plant species, I have taken the reference as control soil plant, first one. Compared to that one, remaining Sesamum indicum plant is showing worst performance. And coming to the cadmium contaminated soil, Sesamum indicum plant is showing good, and Setaria italica plant is showing good in all 3 contaminated soils. Coming to the after 28 days of, I have done chemical analysis at every 1 week of duration, and at the end of 28 days duration, I have observed that heavy metal concentration present in the soil in Setaria italica plant, and the reduction of heavy metal is 20 milligrams per kg and 40 milligrams per kg and 190 milligrams per kg of soil in cadmium and copper zinc contaminated soils respectively. Coming to the Sesamum indicum plant, the reduction of heavy metals after 28 days of duration is observed that 11.5 milligrams per kg, and no reduction was observed in copper contaminated soil in Sesamum indicum plant, and 135 milligrams of per kg of soil observed in zinc contaminated soil in the Sesamum indicum plant. Coming to the Vigna radiata, the highest cadmium removal was observed in compared to other 2 plants also, 21.31 milligrams per kg of soil. It is almost equal to Setaria italica plant, and coming to the zinc contaminated is also showing good after 28 days of chemical analysis. Coming to the conclusions, we have experienced that Setaria italica plant is showing good results toward all the 3 heavy metal contaminated soil, and also Vigna radiata is showing good results from the heavy metal contaminated soil. These are the references I have followed.
Okay, thank you very much. Nice. So now I think really we are reaching to end, and Professor Dr. Ankit, co-chairman of the session, please quickly. You also summarize the session.
Yeah, thank you, Professor Vaidya. I think this session has included some wonderful presentations, especially starting with theme lecture by Professor Tyagaraj. We do not have time to thank him, but we like to thank Professor Tyagaraj for his excellent presentation, especially giving fundamental insight into fundamental behavior of compacted clay under different salt concentrations. And regarding our 13 presentations, although some speakers were not there, majority of the presentations, I think 4, were on usage of fly ash as a material to look into for soil stabilization or soil remediation. And there has been interesting presentation using MICP by Ms. Kavya. I think Ms. Kavya can definitely look into or contact Professor Nilima, who is also an expert in MICP technique. I'm sure she could find a lot of insights or reflection into her work. And also last presentation, which we have seen from Mr. Raj Shekhar. Just a minor comment to Mr. Raj Shekhar. It is interesting to use vegetation for heavy metal decontamination. However, I suggest to also do statistical analysis because plants are highly variable. Having one value or having one average value may not be enough to conclude. So that would be something and also for long-term behavior. Okay, so these are just with this I would like to conclude this session, and I would like to thank Professor Vaidya and Dr. Nilima for the efforts in coordinating and chairing the session. Yeah, thanks. Professor Vaidya, Dr. Nilima.
Yeah, I think we can conclude the session.
She was enjoying because last year you were working hard.
Okay, we conclude this session. Finally, good evening to all of you, and we can.
Hello?
Hello. Yes, I think we concluded. Yeah, it is okay. Yeah.
Hello? Yeah, I think we can conclude this.
It's okay.
Thank you so much.
Going on, no problem. God is great. Good.